Roger that, Monica. See you on the other side.
Thank you. Good afternoon, everyone. After lunch, welcome. First of all, thank you, all of you, for joining us today at this session. Yeah, it's really great to be here. It's really great to see you all, professionals, just eager to explore the future of business operations and how to use potential and power of AI to drive into meaningful changes. My name is Andrzej Błaszczyk and I'm representing ABBYY company. We're located here in Krakow and we help companies and organizations in their digital transformation journey. Also, for more than 25 years, we are proud partner of ABBYY. So, working together with ABBYY, we help companies to bring cutting-edge solutions like intelligent document processing, process mining, and task mining to businesses across the world. Before we dive into the world of AI and process automation, let me introduce today's speakers, my colleagues from ABBYY, Edward Putra and Carlos Alvait. Together, we'll look beyond the AI hype. We'll uncover real and actionable insights into how you can use AI and EDP solutions into business operation changes. So we don't have much time. So Edwards, the floor is yours. Thank you.
All right. Hi guys. Great to be here. So definitely, AI is everything. Everybody's talking about AI. Nevertheless, the feeling is also nowadays that we kind of need a little bit to define what we mean by AI, because there are different kinds of AI that actually we are already using for quite a long time. So typically now, when you're talking about AI, people are mostly imagining generative AI. And from that, of course, immediately the question from my side, the previous session I saw also Dominic was asking, who is using AI. I would ask, who of you are not using generative AI like a chatbot? Is there somebody who has not tried it? Nobody. That's okay. No judgment. That's good. That's good. All right. That's good. So we are already on the same page. So that's definitely powerful technology. Nevertheless, so what we see also when we start to work with our partners and customers, that there could be some nuances there, because of course generative AI, it's still part of, by example, machine learning. Machine learning meaning that also software system can train itself to and learn to improve the performance. So we are actually utilizing in intelligent document processing machine learning for decades. Additional to that, we have also a natural language processing as well, utilized technology for decades, also meaning that we can understand the text, we can understand understand the context of meanings of different sentences and etc. And how we approach those technologies is we are focusing mostly on like a purpose-built AI. So what it means that for the system to be effective, it makes sense also from our experience to focus on specifically built AI for some specific applications. So by example, we can utilize also a neurosymbolic AI together with generative AI. What we mean neurosymbolic, the neuro part is, if you can imagine, like a chess game. The neuro part is the pattern recognition. So we identify different patterns and understand also what they mean. And the other part is a symbolic one. So we are talking about like specific rules. Also specific chess rules where different figures can go. Now, how we see now, most of the people using like generative AI, they are just throwing a document, by example, at a chatbot and then see what happens. Of course, in like real life scenario in an enterprise environment, this will not work for also a couple of reasons. So the first one is hallucinations. That's also quite typical, because in an essence, what Gen AI means, it's a non-deterministic system. So you never know what you'll get out of it. So that's already a problem. Another part is also, it means that it will use probably a lot of tokens. So basically how much information you feed into Gen AI. So it already, here you come also additional risk in terms of cost. It will be difficult to control. Also the third part is context window. Some models will have limitations to that, so you're cutting off a lot of information what's contained in the document. And of course there also are transparency and trust issues to that as well, because you never know, in most of the cases still, on what data actually this LLM is trained on. And to quickly illustrate, how this can really, how you can get the different answers depending on really like a small bits of information. So also recently, some scientists, like 2 weeks ago, scientists published a paper together with Apple, so to really understand what was the actual capabilities of reasoning for AI models. So example was, so let's say Pavel goes to New Zealand to pick kiwis. In this case I mean fruit, not the bird. On Fridays he picks 44 kiwis. Then Saturday 58. Sunday he picks twice as much as on Friday. So that's relatively simple also for large language models. Answer, also not always. Answer is, somebody maybe knows. I like that some people are actually calculating. It's fine. I love it. Thank you for that. 190. Now, what happened next? Also, people, the scientists were asking the even frontier models. Okay, that's fine. But on Sunday, Pavel picked also 5 smaller ones. It completely threw the model off. Because also the reason capabilities was not there to identify how actually important this information is. So of course the results were off. And as you are using large language models, you can test it out and send me your findings via email. You will be surprised about the results. So basically you are just praying it will work. A slightly better method is you can put it through the OCR, recognize, then also do some additional coding. You can a little bit bring it down. Also the cost hallucination still not there. Quite difficult. It's not really on the level of standards that we have. Still a lot of hoping you will get the right answer. And how we are usually doing this as well now, which is also validated by IDC, it's going through a process to make sure that we are feeding like precise information into the different kind of large language models, basically focusing on accuracy, also for the system to accept multimodal input, and putting through the natural language processing. And most importantly, you have this validation step where you can really check if you're really getting results what you want. So in this context, we start to talk it more like a part of the automation platform in the IDP context, starting from things like also like a human in the loop, also that we are validating the results, and based on those also we continue to train our specific built models for specific tasks. Where else we can see a lot of traction now is using IDP as a source for the RAG, retrieval augmented generation. So I think that not all people know what it actually means. So what I mean in essence is that if you imagine that you were a student and you are preparing for exam, so first you read the books, so you retrieve the information, then you kind of putting out most important parts, sticky notes and stuff like that. You augment this information, then an exam, then you generate the right answers. And because we really focus on understanding the document structure, the important information, we can feed the right data into the system. And we actually already have a couple of projects running on the large amounts of documents to really make those models more precise. And this is kind of typical example as well. If we compare, if you just extract the text layer, in a complex document, for example, different kind of balance sheets, it's not really always you will get the right answer. In our case, when we are using ABBYY platform, you will preserve the logical structure of the document, and it also makes much easier for LLM to get you also based on the chat, but much more precise result, exactly what you're looking for. So you are minimizing a lot the hallucinations, and also you can really get it right. And the reason for that is because we have already pre-built models, which still are trained via machine learning. And this is the main approach, how we have built the platform. So it means that it's low code, no code, focusing on rapid deployment, and still being flexible that you can also incorporate different kind of LLMs and chatbots. Automatically also we have a pre-built connectors for different systems, can be also workflow automation, can be integration platforms as a service, so you can really manage the flow, still have like a built-in capability for the human in the loop, and on the input also ready pre-trained models. And also on 30th of October we are also announcing our own model for the documents, so you can also automatically pre-train documents from scratch. So it's Ascent event on 30th, you can check on our website. Very, very interesting stuff. Additional to that, when we are going from the automation story, intelligent document processing automation, it's not the whole thing. Because, of course, if you're talking about the documents, document flow, it's always connected to some kind of process. And to understand where it makes sense, by example, for us to introduce AI agents, different kind of automations, we need to understand the process itself. And for that, we also have a capability of using process intelligence methodology to understand what really happens with our processes, where are potential bigger risks. Because typically what we have mostly will be some risks we can manage. We already know that something is not working. Interesting one is also we have some known unknowns, meaning yes, we know there are some bottlenecks, we have issues in our process, we just don't know the root cause. Probably there are also unknown knowns in the process. We have a deviations that some people maybe know, but it's kind of hidden from the management. And of course, some dangerous things, which can be also against some compliance rules, unknowns. So we have also capability first to understand where we stand in terms of process, and then think, and also after that monitor the performance also of automations or even agents that we create. And with this I give it to Carlos so he can showcase that in more detail.
Yeah, thank you, Edwards. So great. I believe during the last 30, let me put him here, it's better. So I believe during the last 30 years or even more, companies and organizations have been investing a lot of money, a lot of effort in digitizing their processes. And by investing in technology like the ones that we have in the screen, these are just few examples. But even though most of these processes are fully digitized nowadays, it's also true that a lot of inefficiencies still exist because all these processes are getting more and more complex. So when organizations and companies design their processes, they are expecting to create workflows like this one. Very simple, very straightforward. But when we talk to the people that is involved in these processes and we ask, how do you think your processes are working? They said, well, I think my process is getting a bit complex, so I think it's working to like something similar like this, right? But the truth is completely different, right? The reality is that complex processes are getting very, very complex. And behind this complexity, of course, we have an important problem around performance, right, and efficiency. So all these inefficiencies can be categorized in 7 main categories. So the first one is lack of transparency. With this complexity, it's very difficult to have a full visibility and traceability of the different business processes. Then we have bottlenecks and reworks. This is one of the most common problems that we can identify. Then we have compliance and audit challenges. Of course, if we don't have enough transparency of our processes, it's very difficult to control how our processes work. Then we have lack of standardization. As we could see, processes are never executed exactly in the same way. So we have too many variants, and these variants produce a lot of inefficiencies. Then we have issues around resources. In some cases, we have overburdening of resources. In other cases, we have under-utilization of them. This is also a very common problem. Customer experience. Again, if we don't have the tool to monitor our process and to understand how the process works from an end-to-end perspective, it's very difficult to know how the customer journey is working. And finally, another very important challenge is how to identify opportunities for automation, right? This is, I would say, one of the most common use cases, right? So what we do to address these challenges is basically we take advantage of the data produced by all these systems supporting the different business processes, right? Transactional data. I'm talking about ERP systems, CRMs, any other enterprise application. So all this system produces a lot of data. So what we do is we take advantage of this data to create a digital representation of the process. And from there, we can start looking for inefficiencies, root causes of these inefficiencies, impact in the business, and potential improvement. So I'm going to switch now to ABBYY Timeline, our process intelligence solution, to show you a quick demo, a quick overview of how it works and what kind of use cases we can explore, right? So give me a second because so the idea is to give you an overview, and after the presentation, if you are interested in knowing more, we can have a more detailed conversation. So Good. So once we load, the example that I'm going to show you is purchase to pay. It's a very common business process. So once we load the data into the tool, we can get the digital representation of the process. So in this example, we can see that everything starts with the creation of the purchase requisition. Then we have the corresponding approval. In some cases, we have rejections. Then we have the creation of the PO, received goods, the invoices, the payments, and so on. So what we are seeing here is basically each one of these dots is a purchase order, right? And if I click here, I can see all the details for this specific purchase order. So for example, this one was created on this day, at this time, then 4 days later, it was approved, and so on, right? So this way we can have very detailed visibility and traceability on the process. So let's assume that now we are interested in identifying automation opportunities. So what else we can do? One thing we can do is, okay, where are the bottlenecks? Because usually this is what we want to remove when we are focused on automation. So in order to identify the bottlenecks, we can use this module, and we can easily identify which are the most time-consuming events. So in this example, we can see that received goods is the most time-consuming one. And actually, from here, we can also estimate how many hours we can save to the business if we, for example, if we fully automate this step. So by changing the average time, we can say, okay, in total we can save this amount of hours. Obviously, this depends on the data set that we are using. This is just an example, right? Another question that we could ask ourselves is, okay, so now that we already identify which are the most time-consuming events, or what's the main bottleneck, what happens if I remove this bottleneck? What could happen in my process if I remove this bottleneck, right? So for this, we can take advantage of the simulation module. So in the simulation modules, we can create simulation scenarios by using artificial intelligence to make changes in our process and estimate the impact of these, or anticipate the impact of these changes, right? So in this example, I created a simulation scenario in which I fully automate the received goods event, because this was the main bottleneck, right? So the change that I made was basically replacing human labor by an RPA solution, right? So if we check the results, in this example, we can see that actually this change is something positive, because if we check, in the second line is the as-is, the second line is the as-is of the process. We can see that performance is 27 days. But after this change, if we check the first line, which is the simulation scenario, we can see an improvement. So we are going from 27 to 23 days. So in this case, this change is positive. I can tell that in real scenarios, usually we remove a bottleneck at the beginning of the process, but then we produce another bottleneck at the end. So this is why this tool is so powerful, because we can anticipate this kind of changes, this kind of issues in our process without making changes in real life, right? So now as a next step, another thing we can do is, okay, so now that it's clear that removing these bottlenecks is something positive, the next step is, okay, what are the tasks that are being executed by the users every time they need to receive a good? So for that, we can use task mining. So with task mining, we can also capture the actions executed by the users in their computers, right, to get full traceability on this task that they do, so that we can then design the corresponding automation solution. So in this example, we can see that the user was doing something in their browser, right? When they have to receive a good. So for example, he was using SAP, then the user switched to Outlook. If we check in this example, we can see, actually if I double click here, we can see the screenshots of the actions performed by the user, right? For example, here the user was saving an attachment and so on. So the tool automatically will give us a summary of what are the best automation candidates, right? And also will tell us how much money we can save, how much time we can save if we fully automate each one of these tasks. And also we can easily identify where to start by using this chart. So the best candidates are the ones that are on the right side and the bottom, because these are the ones that will give us more gains and with less effort, with less complexity. Of course, we can also analyze how much time the user is spending on each one of the applications and so on. And again, in this module, we also leverage artificial intelligence and our experience in IDP to identify all the tasks executed by the user in their computers, because what we do is capture screenshots, right? Basically, right? So this is one of the most common use cases. There are many more. I think I have time to present another one. Another very common is conformance, right? So, and in this solution, we can easily define process reference modules, and we can compare how the process is performing versus this specific module that we created, right? So in this example, as you can see, we have the most standard sequence of steps of the purchase process, and also we included some SLAs between some specific steps. So, for example, invoices. What we are saying here is that invoices must be received in less than 5 days. Otherwise, we have a problem. So, if I click on violations and we focus on specifically on this one, we can see that 33% of the cases, or 33% of the invoices, were received late. So, if we want to go deeper, we can focus on these cases, and we can take advantage of the additional data attributes that we included in the data set to identify, for example, who is the vendor responsible for these invoices. So in this example, we can see that vendor B is responsible for 38% of the invoices that were received late, right? Followed by vendor A, and so on, right? And apart from that, apart from identifying the root cause of the issue, we can also create alerts to notify users when these kind of behaviors are detected, right, in real time. So these alerts can be sent via email, or we can also trigger actions on external systems like RPA solutions or the ERP to do something. For example, to change the priority of the invoice in this case, and so on, right? And another thing we can do is, by using artificial intelligence, is we can train machine learning modules to anticipate outcomes in the process. So, for example, here we can see, I have an example here. This is a notification that we have in a real project with a customer in Japan. It's FedEx, we can say it. So they are using this to anticipate which deliveries are going to be late, right? And the tool can anticipate that by using machine learning, taking advantage of the transactional data loaded to create these models and be able to anticipate this kind of outcomes. So these are just few examples, right? So the idea is, if you want to know more about this technology and you want to discuss more detailed use case, we are going to be around here, so feel free to get in touch with us, okay? Thank you very much.
Really good. We still have time for questions. Do you have any questions? I see there's a lot of also PwC guys. Like I think some parts were a little bit familiar for you.
I do have a question.
Okay.
So I understand that this is all based on data from systems. And from the process, taking the example you took, purchase process, there are elements of the process that is outside system. So how do you handle those?
There are elements.
There are steps within the process that are outside of the system.
Yeah.
For example, you send a purchase order to a vendor, and the fact that you take X amount of time to receive or to do the GRM, it really depends on the supplier. So how do you handle those that are outside of the system?
So for that we have task mining, right? I explained it very, very quickly. Sorry for that, but with task mining, what we can do is we can capture actions executed on external systems, right? So normally users they have the ERP or their CRM, but they also have to use Outlook, they have to use Teams, third-party applications to complete each one of the tasks. So we can basically capture these actions by installing an agent in the computer, right, to capture these screenshots.
So the time that you calculated that, for example, how much time does it take to do the goods receipt is really just based on the actual tasks of the user and not the overall, let's say, timestamps. Because I can imagine from the moment that you send the PO to the moment that the agent do the goods receipt, there is other things that is not on the agent.
Correct. So at the end, with process mining, you can basically take advantage of the data produced by the ERP, for example, in this example, to get the end-to-end view of the process, right? Including each step, right? But with task mining, what you can do is zoom in on each one of these steps of the process. So with the timestamp, you can know what's the total time that is needed to receive a good, right? But with task mining, you can get into the details, and you can know exactly how much time the user is spending on each of the tasks that are necessary to complete this specific step, right? So at the end, process mining is an X-ray of the process, right? And task mining is like using the microscope, you know, just to zoom in. We always recommend to start with process mining and then switch to task mining, right? Some of our clients, when they say, when they see the task mining module, they say, no, I want to start with task mining because I want to automate this and this and this task. But if you don't analyze the process from an end-to-end perspective, there is a big risk of automating tasks that are not efficient. And if you automate something that is not efficient, it will be exponentially inefficient. That's why we always recommend to start with process mining to make sure that all the steps in the process are optimized, and then switch to task mining to automate the manual events, right?
Also adding to that, for the things that are not in systems of record, like a data points, we have some first use cases where Gen AI is used as well. So one of example is the incident management for like incident reports, because usually you will not have like a precise data points regarding the reasons or reason types. So one of our partners use Gen AI to kind of extract the key elements and add into the event log, which I think is very interesting use case for that.
Yeah.
So the model looks great. How much time is needed to gather all the details to start such analysis?
It's a good question. The key part of any process mining initiative, or I would say the most important stage, is the data collection part. And this is, I would say, the most critical part, because we need to collect data from the different source systems. And for this, we have multiple options, protocols, connectors, and so on. And once we collect the data, it's important to prepare the data, right? So usually it depends obviously on each case, right? But for example, in the insurance industry, we can maybe be ready in 1 month in terms of data preparation. But if we are talking about manufacturing industry, in which we have the ERP and other systems, it could take 3 months, for example, just for the data preparation part, right? Once the data is ready, then we can start with the analysis. And usually each use case takes 2, 3, or 3 weeks. And using ABBYY Timeline, because ABBYY Timeline is a no-code solution. This is one of the main differences between this tool and the other tools in the market right now. So this one has been designed for end business users, which means they don't need to know how to code to build this analysis, right? I did not explain that because we have little time, but of course we can build dashboards, right, to complement this analysis. Because at the end, what I showed you was some specific pre-built analysis tools that we have, like for example the bottleneck, the simulation, and so on. But we can also build dashboards to consolidate the result of the analysis, right? And dashboards are very useful to deliver insights, especially to top management levels. So for example, for the automation analysis that I explained, we can see what's the total automation rate of the process, what's the total cost of the manual events that we have, which at the end is the opportunity for improvement. What are the most time-consuming events? For each one of them, how many are executed automatically, how many of them are executed manually, and so on. So an analysis like this can take 2 or 3 weeks using this tool, assuming that the data is ready. But again, data preparation is very important, it's very critical, because at the end, if the data is not good, then the results cannot be good. You're welcome. Any other question? Yeah?
I just wonder, I mean, here it's how much you can get out of this if you automate or optimize particular process. I suppose it's happy flow versus unhappy flow. If you have happy flow, then everything goes kind of smoothly, it's automated, right? If unhappy flow, it's kind of causing these bottlenecks. Do you also apply anyhow benchmarking here? So to say, let's say this is the happy flow in this company, but still it's far away from the benchmark. How good could it be? So I just try to see, is it only this company process mining, or also we can see how the others technically do it? And how
I would say that, I would say that this is this is the responsibility of the consultant, right? But now what we can do is we can do benchmark in the same company, of course. So we can do comparisons because in most of the cases there are some variants that we call the happy path, which works well. So we can do comparisons against these happy paths, right? And there are many different ways of doing these comparisons. For example, we can do side-by-side comparisons, like we are seeing right now. So we can compare workflows side by side, or we can also make comparisons in terms of some specific KPIs, like costs, like duration, and so on. But if you want to make benchmarks outside the company, that depends on the implementation team. Cool. Any other questions? No? Okay, good. Thank you very much.